Somewhere in suburban Phoenix, a family is running their air conditioner right now. They will run it tonight, they will run it tomorrow, they will run it every day from April through October, and their electricity bill will reflect every single hour of it. Last summer, their cooling costs alone exceeded $400 in a single month. The month before that, $380. The month after, $360. They insulated properly. They replaced their windows. They bought a smart thermostat. They did everything the industry told them to do. And still, the house bakes. Because no one told them the real problem isn't the air conditioner. The real problem is the wall. Concrete and standard timber framing, the materials used in the overwhelming majority of American homes built in the last 70 years, absorb heat during the day and release it slowly back into the living space at night. Builders call this thermal mass behavior. Homeowners call it the reason the house feels like an oven at 10 in the evening even after the sun went down 3 hours ago. The wall itself is the enemy. Now travel to the south of France, rural Burgundy, a farmhouse that has stood for over 300 years. No insulation has ever been added. No HVAC system has ever been installed. Summers that push past 90 degrees Fahrenheit pass through the region every year. Inside that farmhouse, even on the hottest afternoons, the air is cool, not air-conditioned cool. Naturally, permanently, structurally cool. The walls are made of hemp. If you've never heard that before, you're not as alone, and that's exactly why this channel exists. Before we go further, if this is the kind of buried knowledge you've been looking for, hit that like button right now and subscribe to Lost Tech Vault. We dig up the solutions that got pushed aside, forgotten, or quietly suppressed, and we explain why. You won't want to miss what's coming next. Now, back to the hemp wall that doesn't need air conditioning. The material is called Hempcrete. It is not new, it is not experimental, it is not fringe. Hempcrete structures have been documented in France dating back to the 6th century. A bridge foundation in the Rhone Valley, analysed in the 1980s, was found to contain a hemp and lime composite estimated to be over 1,500 years old. Still structurally intact, still chemically stable. For centuries across Europe, builders who had access to hemp used it, not because it was fashionable, because it worked better than the alternatives. Then, in a compressed period between the 1930s and 1950s, it effectively disappeared from mainstream construction across much of the Western world. Not because a better material replaced it, not because it failed structurally, not because builders abandoned it by choice, it was legislated out of existence. In 1937, the United States passed the Marihuana Tax Act. The stated target was cannabis used as a drug. The practical consequence was the near-total criminalization of industrial hemp, a plant so botanically distinct from its psychoactive relative that until the 2018 Farm Bill, American farmers couldn't legally grow either without federal permits almost impossible to obtain. The timing was not coincidental. That same decade, the American concrete and timber industries were undergoing massive consolidation and federal investment. The New Deal was pouring money into infrastructure. Concrete was being standardized into building codes across the country. DuPont had just patented nylon, a synthetic fiber positioned to replace natural materials, including hemp rope, hemp canvas, and hemp fiber composites. William Randolph Hearst, who owned both newspapers and enormous timber holdings supplying paper mills, ran a coordinated anti-hemp media campaign that historians have documented in detail. The plant was conflated, deliberately and strategically, with drug use. Within a generation, most American builders had never heard of hempcrete. Within 2 generations, it had vanished so completely from the construction vocabulary that suggesting hemp as a building material sounds, to most people, like a joke. It is not a joke. It is arguably the most thermally efficient, carbon-negative, naturally mold-resistant, humidity-regulating building material available, and it has been sitting in a legal grey zone for the better part of a century because it threatened the wrong industries at the wrong moment in history. Here is what hempcrete actually is and why it performs the way it does. Hemp hurds, the woody inner core of the hemp stalk, a byproduct of fiber processing, are combined with a lime-based binder and water. The mixture is cast into forms around a structural frame, or pressed into blocks, or sprayed using specialized equipment. As it cures, it mineralizes. The organic hemp material slowly petrifies into a lightweight, breathable, stone-like composite. The result has thermal properties that no conventional building material can match at any price. Hempcrete walls don't just insulate, they regulate. There is a critical difference between those two things that most people have never been taught to think about. Conventional insulation, including fiberglass bats, spray foam, and rigid board, creates a barrier. Heat attempting to cross the wall is slowed, but heat that makes it through, or heat generated inside the home, or heat radiating from surfaces already warmed by the sun, has nowhere to go. It accumulates. The interior temperature climbs. The air conditioner compensates. Hempcrete walls breathe. They absorb excess heat when interior temperatures rise and release it slowly when temperatures fall. They absorb excess humidity when air is moist and release moisture when air is dry. The wall itself becomes a passive climate system, continuously buffering the interior against the extremes happening outside. In climates with significant day-to-night temperature swings, including the American Southwest, Mediterranean Europe, Central Asia, and much of sub-Saharan Africa, this buffering effect alone can eliminate the need for mechanical cooling entirely, not reduce it, eliminate it. The French farmhouse that has never needed air conditioning isn't staying cool because of clever engineering or expensive systems. It's staying cool because the wall knows what to do. Now consider how fast it builds. A hempcrete wall panel, preformed, dried, ready to install, goes up with a simplicity that would embarrass most conventional construction timelines. Because hempcrete is lightweight, roughly 1/7 the weight of concrete, standard framing crews can move and position panels without heavy equipment. Because it locks to timber framing without specialized fasteners or adhesives, the assembly process is closer to stacking than to building in the traditional sense. Small hempcrete structures, a cabin, a workshop, a modest single-story home, have been documented going from foundation to enclosed shell in under 3 days with crews of 4 to 6 people. 3 days. A conventional stick-frame home in the United States takes an average of 7 months from permit to certificate of occupancy. Even the fastest modular construction timelines rarely compress below several weeks for full enclosure. 3 days changes the economics of building entirely. Fewer labor hours, less equipment rental, less site overhead, less exposure to weather delays and material cost fluctuations. And when the building is finished, the operating costs change too. Hemp sequesters carbon as it grows, more carbon per acre than most forest replanting programs. The construction process locks that sequestered carbon into the walls. A hempcrete home is uniquely carbon negative before the first resident moves in. Every year it stands, it continues holding that carbon rather than releasing it. The concrete industry, for comparison, is responsible for approximately 8% of global carbon dioxide emissions annually. More than aviation, more than shipping. The question worth asking now isn't whether hempcrete works. 5 centuries of European structures and a growing body of modern engineering research have settled that question comprehensively. The question is why, in 2025, less than 1% of new American residential construction uses it. The answer is layered, but at its center sits something uncomfortably familiar. Building codes are not neutral documents. They reflect the lobbying power of the industries that helped write them. Concrete and timber manufacturers have had a seat at the standards table for decades. Hemp, legally sidelined for most of a century, had no seat at any table. Even after the 2018 Farm Bill restored legal industrial hemp cultivation, the International Residential Code, the model code adopted by most American jurisdictions, still does not formally recognize hempcrete as a standard structural material. Builders who want to use it must often apply for experimental material exemptions, submit engineering studies, and navigate approval processes that can take longer than the construction itself. The material is legal, the knowledge exists. The performance data is unambiguous. The paperwork, by a remarkable coincidence, remains extremely difficult. This is not an accident. When an industry controls both the supply chain and the standards that define what can replace it, alternatives don't disappear because they fail. They disappear because navigating around the barrier becomes more expensive than accepting the inferior product everyone is already approved to sell you. But that is beginning to change. France updated its building standards in 2012 to formally recognize hemp lime construction. The United Kingdom, Germany, Belgium, and the Netherlands have followed. Small American builders operating under research exemptions and working with sympathetic municipal inspectors are completing hempcrete projects in nearly every state. Each building that goes up is a data point. Each data point makes the next approval slightly easier. Each approval makes the next building slightly cheaper. That is how suppressed technology re-emerges, not with an announcement, not with a press release, with one building at a time, standing quietly in neighborhoods where the neighbors slowly start asking questions. The Phoenix family running their air conditioner right now will run it again next summer, unless somewhere between this video and that bill, they learn that the wall itself is the solution that for 1,500 years before lobbying existed and before building codes were written by the industries they were meant to regulate, people built homes out of hemp and lime and lived in them comfortably without a single kilowatt of mechanical cooling. The technology didn't fail, it was simply made very, very difficult to find until now. Subscribe to Lost Tech Vault, because the best solutions are usually the ones someone worked hard to make you forget.